All right, welcome back. Let's look at worksheet 5A on moments. Okay, so make sure that you have completed your, at least you have tried to do first before you actually watch this video because you must try before you actually know where you made a mistake. Okay, so let's take a look. Complete the following sentence. The turning effect of the force is called the moment. Okay, easy. The moment of a force is a product of, remember the two things, force and the perpendicular distance. C. The SI unit for a moment of a force in both words and symbol is Newton meter, Newton and N for is must be capital. Okay. 2. Table 5.1 with the correct direction of each moment include arrows to show the direction of each moment. So we have the pivot. Okay. We have a force here. So remember our clock. We draw the minute hand and the hour hand. If it turns this way, it's clockwise. So we have a force here. There's a pivot here. It turns this way, correct? Turn this way, clockwise. Okay, so it's a clockwise moment. Next, the pivot is here. We have a force here. It turns this way. Look at our clock. Our clock is in opposite direction, so this is the anti-clockwise moment. So anti-clockwise moment. Okay. Okay. Next, figure 3. Sorry, figure 5.1, question 3 shows two forces acting on the light beam pivoted at the center. So this is still like a seesaw. 400 newtons on one side, 600 newtons on the other side, 1.5 meters from the pivot and 1 meters. Calculate the clockwise moment of the 600 newton force. So they really ask you, they give you a hint. I want a 600 newton force. Can you tell me what is the moment? So this side is clockwise. I just write it down. This side is anti-clockwise. Then you ask me, so why is it clockwise? Why is it anti-clockwise? Similarly, remember our clock. Our clock turns this way. This is clockwise. So your pivot is here. Pivot. 600 turns downwards like your clock. So it's clockwise. The other one turns the other way, which is anti-clockwise. So let's calculate the moments. Clockwise moment equals force times distance. Very important to write your formula first. So if you do not have your formula, please write it down now. Next, let's put in a number. The force is the 600 newtons. What is the distance to the pivot? Force, you see the dotted line. This is the line of action to your pivot. This is the perpendicular distance. Why perpendicular? Because it's 90 degrees. So remember, it's 1 meter. So this is 600 Newton meters. Make sure you have your units, Newton meters. So this is clockwise. So the question they ask is calculate the next one, calculate the anti-clockwise moment out of 400 newtons. So similarly, anti-clockwise moment equals to force times distance. Write down the formula. Do not have. Write it down now. What is the force? 400. What is the distance? 1.5, the perpendicular distance from the pivot. Remember, I keep emphasizing on the pivot, from the pivot. Okay, so that will give us a 600. So, 600 here, 600 here, clockwise, anti-clockwise. What does it mean? Yep, the clockwise is equals to anti-clockwise. By the principle of moments, the forces acting on the beam are in equilibrium. So what it's trying to say is that the principle of moments tells us that the clockwise moments is equals to the anti-clockwise moments about the same pivot. So if that is true, then this beam or whatsoever, is this a beam? Yep, the light beam, it is in equilibrium. Okay. All right, let's come back for the next lesson of that for the principle of moments.